Hello, Chemistry 10HH students. This is Mrs. Altman, and in this video, I'm going to be working through the video number 42 in class practice. You should already have access to that document as I gave it to you along with the final exam study guide. I know I'm not going to be able to make it to school tomorrow, so I'm going to work through those problems right now. I'm just going to work through them one by one. So starting with N2. Each nitrogen likes 5 valence electrons. You could just do dots. I'm just doing circles because it's easier with the tablet I'm working on. And it's going to be easier for you to see where I connect them. So each nitrogen has 5. It wants 8, so it's going to bond 3 times. For right now, don't worry about where you put them. I just care that you have the correct number of bonds and lone pairs. All right, moving on to the next one, O2. They each have 6, so they're going to want to bond twice. So 2 bonds and then 4 non-bonding electrons on each. Next we have I2. So each one only needs to bond once, 1 bond, and then they'll have 6 electrons around each. And then Cl2, at this point you might recognize that Cl and I2 or Cl2 and I2 might have the same pattern. So if you can already figure out what it's going to be before you do it, go ahead and do so. Okay, for CO2, I start by putting carbon in the middle, and then I surround it by oxygens. Each oxygen wants to bond twice, the carbon wants to bond 4 times, and it conveniently works out. It should pretty much always conveniently work out with very few exceptions. And then you could redraw it, make it look nice, but you don't have to do that. Oops, didn't mean to do that. So now on to C2H4. So I'm going to put the carbons in the middle and then just sort of surround them evenly with hydrogens. Hydrogen's weird. It only needs to have 1 bond because it's fine with having 2. Carbon still wants 4. And then the carbons will have to bond with one another. And you can leave it like this for now. I'm going to show you how to rewrite them to make it look nicer later. I'm now up to G. Each hydrogen must bond once. Sometimes when I see students do these, they try to bond like 4 of the hydrogens to one of the carbon and 2 to the other. You always have to have a continuous line from one end of the molecule to the other, meaning they all have to be connected in some way, which is why this is the correct structure for this. Now on to H. Placing these just sort of evenly around it. So I'm going to connect all of the hydrogens to the carbons, and then I'm going to bond the carbons to one another afterwards. So then it just appears to me that single bonds are the best way to go. So that is that structure. Now for CO3 2 minus. I start by not considering the 2 minus. Right, now I've got 2 minus. That means I have 2 extra electrons. Oxygen is the more electronegative element. So I have to pick 2 different oxygens. I can't put both of them on the same oxygen. So I both add an extra electron and I label the charge. So I have to do both. I add the extra electron and I label the charge. Now, this oxygen has 6, so it wants to bond 2 times, and then each of these have 7, so they only want to bond 1 time. And it does not matter which of the 2 oxygens I picked. I could have picked any 2 of them. The 2 that have the negative charge should have a single bond. The one that doesn't should have a double bond. J is a little bit weird. I'm going to work through it, but if you're having trouble understanding it, it's not really anything to stress about. This is like a one weird exception. Right, so it's NO3 minus, so I'm just picking one of them. I'm adding an extra electron, and I'm labeling the negative charge. So this one wants to bond once, and then a lot of students are tempted to say, oh, let me just bond it twice and twice, because that's what the oxygen wants. But nitrogen's weird. Nitrogen cannot break the octet rule. So this is incorrect what's on the screen. So let me get rid of what I just did. So if you get to this point, what I'm going to do is I'm actually going to remove an electron from nitrogen and move it to oxygen. So I moved it. So in removing it from nitrogen, nitrogen now has a plus charge. I could label it plus or plus one, both ways fine. And then this oxygen has a -1 charge. This is a weird case. This doesn't happen often. So if this is not super clear to you, it's not really anything to stress about. You're not really going to see it pop up too much. Okay, moving on to NO2. I pick one of the oxygens and give it a -1 and an extra electron. That one only wants to bond once. The other one wants to bond twice, which works out nicely because nitrogen wants 3 bonds. Now for SO3. Each oxygen wants to bond twice. Sulfur, left to its own devices, would want to bond twice, but it is capable of bonding more. It is more important typically to make sure that the elements on the outside of the element have their ideal number of electrons. Sulfur can have more than 8. It's allowed to. Anything that is in the third row and below can do this. Just because it can doesn't mean it has to. It just means it can. If you already know that something's going to have non-bonding electrons around it, you can represent it with these lines instead. I'm not going to do that here, but just letting you know that you can. Each iodine wants to bond once. Sulfur is capable of doing that. I pick two oxygens. It doesn't matter which two I give it. I give them an extra electron and I label the negative charge. The two that have the negative charge have 7 electrons, so they only want to bond once. The ones down here that don't want to bond twice. And sulfur has just enough electrons to make it happen. It usually works out like that. The only exception was that where things really don't work out was the one on the first half, the one that's labeled HH only. Each chlorine wants to bond once, and then silicon wants to bond 4 times. This one just worked out. You didn't have to do anything with breaking the octet rule. Some of you are probably sitting here thinking, can't xenon not bond? It's a noble gas. Noble gases can bond. It's just not super common. Oxygen wants to bond twice. Everything else wants to bond 1 time. And then xenon has 2 leftover non-bonding electrons. That will be important a little bit later on. Each fluorine wants to bond once. The phosphorus wants to bond 3 times. It coincidentally works out, or not really coincidentally, not at all coincidental. I pick 3 of them. It doesn't matter which 3. I give each of them an extra electron. The 3 that have that extra electron want to bond once. The other one wants to bond twice. Phosphorus is okay with this, even though it would typically prefer 3. It can have more because it's in the 3rd row or below. When it comes to polyatomic ions, you can never add or remove from hydrogen, so you don't even need to think about which one is the more electronegative element. You're just going to remove one from nitrogen, label the charge with plus or plus 1. And now it has 4 electrons, so it wants to bond 4 times, and then it is surrounded by 4 hydrogen atoms. Same thing here. I have to remove from oxygen. I cannot remove or add electrons from hydrogen. So I remove one, I label the charge. Oxygen now has 5, so it wants to bond 3 times, and it is surrounded by 3 hydrogen atoms. I'm going to hold off on W and X because I don't think that the video format's going to really lend itself to explaining it well, but they're not the most important examples anyway. All right, I hope that this works out. I hope to see you all soon. Happy Color War. Have a good night.